this on? Do you want this on? I'm more comfortable if I take it off. I just don't want to do it in front of the other ones. Okay, done. Let's go. So, displacement, velocity, acceleration. So, x dot and x double dot is your first and second derivative. You understand that, right? So x dot, x double dot, first derivative, second derivative of the original. And it's important to understand acceleration is also your first derivative of velocity. That will be very useful. So it's the second derivative of displacement, but it's also the first derivative of velocity. So if we're going down, we're obviously going to be differentiating, and if you're going to go up, you're obviously integrating. So if you had acceleration, you're going to move to velocity, you'll do that by integrating. That all makes sense. Everything's going to be in terms of time in your course for advanced. Yep, it'll be in terms of time. In extension 1 and extension 2, for example, with you, Azra, it won't be, so we'll have to do things just slightly different formulas, but the logic is actually still the same. What else do we need to know? We need to know a few different words. So I think that's when I'll open up this booklet and we'll talk about different words. So these words are that. There we go. So the first word is, okay. So with displacement, displacement is a means of giving the position of an object from a central position, the origin O. Be careful, displacement does not mean distance. So displacement is different to distance. So if, for example, if I told you here's a line, this is the origin. If I went 2 meters this way, then 2 meters back, my displacement is 0. My displacement is 0 meters. But my distance is obviously 4 meters. So be careful, displacement's a bit different to distance. So when we ask for distance, everyone thinks that they can just go and find x. It doesn't exactly work like that because x is displacement, not distance. Distances can't be negative, whereas displacement can be negative. So distance is pretty much how far away you are from the origin. So that's it, simple. A few important things to understand. We'll only focus on the position of this object along a straight line. So a positive displacement means the object is to the right of the origin. So keep that in mind. If you get a positive x, that means it's to the right of the origin. If you've got a negative displacement, it means it is to the left of the origin. If you see the word initial, initial always means when time is equal to 0. And of course, if the object is at the origin, the displacement will be at 0. So if the object is at the origin, its displacement is 0. The biggest ones that everyone knows is obviously these two. The ones that everybody doesn't know and they love testing in exams are these concepts, I guess. So just be aware, these are really important. I'll scroll down. We'll come and do all the questions, obviously. But let's just learn these little definitions. So velocity is, like we said, it's the rate of change of your displacement. So in other words, it is your first derivative of your displacement function. Velocity is the first derivative of the displacement function. The velocity gives both the speed and the direction of an object. So if you've got a negative velocity, it means that an object is actually moving to the left. So remember, that's different to displacement, right? Displacement being negative, what did it mean? Displacement negative meant the object is to the left of the origin. So if we were to interpret something just quickly, if I put them together, if I said x is less than 0 and x dot is greater than 0, that means it is to the left of the origin of origin, it is to the left of the origin, but x dot means it is moving to the right. How are you, Alex? Come, grab a seat. Did you bring a little laptop? Yeah. Perfect. Grab a seat. So x less than 0, it is to the left of the origin. Do you get that, L? So it can be to the left of the origin. X dot greater than 0 means that it is moving to the right. All right, brilliant. Hello, hello. Grab a seat. Yeah, right here. Will be good.